Okay guys, so our goal for this set of notes in 9.6 is to be able to solve for a variable in the exponent, which is a question that we've really, or a goal that we've really been working with over and over and over again in this chapter. So this idea isn't new. For example, if I have an equation, 3 to the x equals 9, and I ask you to solve for x, notice x in the exponent, but that's really not that bad. You guys know your perfect powers, and so you know that x has to equal 2. And that's easy enough. However, if I look at example 2, 3 to the x equals 15, well, now we're in a little bit of an issue, because that's not going to be a nice number. 15 is not a power of 3. 3 might be a factor of 15, but it's not a power of 3. So we're going to have to get a little bit more creative here. Now, we would know that the answer must be between 2 and 3, because 3 squared is 9 and 3 cubed is 27. So we've got to be somewhere between there, but could be any decimal in between that, or in between those two integers. Now, in the past, one thing that we would sometimes do is rewrite the function in log form, but that won't necessarily help me here either. In log form, that would be x equals log base 3 of 5, and the issue, or sorry, 3 of 15, and the issue is I can't plug that into my calculator. It has a base of 3. So we need a new method. That is fine, but this doesn't help me. So one thing you may remember from Algebra 2 is in this situation, when we need to solve for a variable in the exponent, we can take the log of both sides. Now when I write this, I don't have to write the 10, but it's implied to be there, so you can put those in if you want. The reason this is going to work out for us is that we are able to plug logs with a base of 10, or a common log, into the calculator. Now this also requires a little knowledge of your log properties. We would want to take this x, it's the exponent on 3, and we get to move it to the front of the log. Now log base 10 of 3 is some number, and that number is multiplying the x, and we would like to get x by itself. So we are going to divide both sides by the log of 3. And that actually gets us what we call the exact answer. The answer that requires no rounding whatsoever is log 15 over log 3. Both of those logs have a base of 10. Again, you can write the 10 in if you want, but you certainly don't have to. Again, logs that have a base of 10, we can plug those into the calculator. So log 15 divided by log 3 gives me an approximate answer. I usually recommend rounding to 2 decimal places of 2.46, and that certainly makes sense with what I said up there. I always like to make sure my answer makes sense. One thing that I sometimes see people do, which would be incorrect, is that you can't cancel out the logs. That's notation. Notation doesn't cancel out. You're not multiplying the 15 by the L and the O and the G. So division isn't going to cancel that out. It's not actually multiplication between those things in the top. Now, crucial thing, when we're solving for x in the exponent, you must get the base by itself. Okay, that wasn't so much of an issue up here because our base was 3. There was nothing else by the 3, so it was easy. But you can see in these next two examples, It's a bit more complicated. All right, so on the next one we see that we have an e there. Anytime I see e, I usually think, oh, a natural log might be a good idea. And we might use a natural log here in a moment. But our goal is to get this variable by itself, and it is in the exponent. So eventually I'll be using a log. That's what we do when we have a variable in the exponent. But that 4, this 4, is not raised to the 3x minus 5. So we're going to take that 4 and first divide it to the other side. And I get an e to the 3x minus 5 equals 18. Okay, well, now the e, that's our base, is by itself. So this time I'm going to take the natural log of both sides. I could take the common log of both sides, but because there's an e in there, I think the natural log is a little easier. Take the natural log of both sides. Now I get to move that 3x minus 5 in front, and I will want to see that we put that in parentheses, because it's not just the minus 5 that's multiplying the natural log of e. The whole thing is multiplying that natural log of e. The other really cool thing, though, the natural log of e is just equal to 1. What exponent do you put on e to get e? No, it's just an exponent of 1. So I'm left with a 3x minus 5 equals the natural log of 18. I'm going to add the 5. I'm going to put that 18 in parentheses so I know that that's on the inside and the plus 5 is on the outside. And then divide everything by 3. And that gets us x. This is my exact answer. And then that is approximately, so when I plug this in, we're going to do natural log of 18, close that parenthesis around the 18, add the 5. I like to then take that answer and just divide it by 3. If you want to plug it in all at once, you would have to put the entire numerator in parentheses as well. So we can do that too. Oops. I hit the wrong thing. Hold on. Divide by. There we go. So 2.63 is our approximate answer. Okay. So let's look at another one here. The 5 is our base, and we're trying to solve for that variable in the exponent. So I got to do a little work on getting that 5 by itself. I'm going to subtract the 1. When I divide by 1/2, that's the same as multiplying by its reciprocal. So I have 5 to the x minus 2 equals 24. Now I could take the common log of both sides. I could also take the natural log of both sides. In this instance, since e is not in here anywhere, one is not necessarily easier than the other. So I think I'm going to go back to a common log of both sides. We're going to move the x minus 2 in the front. Log 5 is just a number, and it's multiplying that x minus 2. So I'm going to divide it to the other side. So I have x minus 2 equals log 24 over log 5. I'm going to add that 2 to the other side. This is our exact answer. And then when we plug that in, we're going to do log 24 divided by log 5. Close that parenthesis around the 5 and then say plus 2. And we have 3.97 as our approximate. Okay. So, when you guys go to the back page here, I have 3 examples. I want you to pause the video and complete these 3 examples, and then go on Blackboard and look at the answer key for these 3 videos to see how you did. Alright, and if there's any questions on any of these 3 examples, we'll be sure to talk about it tomorrow.